let A be a symmetric matrix of order 2, means A is a 2 cross 2 symmetric matrix with integer entries. So each entry of that matrix must be some integer. It is given that sum of diagonal elements of A square is 1. Sum of diagonal elements means trace of the matrix. So for matrix A square, trace is 1. Then we have to find the number of possible matrices. Now in this problem, the keywords are that A is a 2 cross 2 symmetric matrix with integer entries. Now remember that in case of symmetric matrix, the definition of symmetric matrix is that A transpose, this is same as A. And another way of saying the same thing will be that element in ith row, jth column, this is same as element in jth row, ith column. That means the matrix is symmetric about its principal diagonal, right? So here, for example, if I have to take a 2 cross 2 symmetric matrix, first we'll start with a general 2 cross 2 symmetric matrix, and the trace of that matrix will be, trace of A square will be 1. So from there, we'll try to find an equation in variables, and then we'll see what are the different integral values of those variables which will satisfy that equation. So in case of symmetric matrix, you can have anything on diagonal, but these two elements must be same, right? Element in first row, second column, this must be same as element of second row, first column. The matrix must be symmetric about its principal diagonal. So let us say this is matrix A. Now if this one is matrix A, then A square will be matrix A into matrix A, right? A square means A into A. So we'll write the same matrix again, and then we'll see what should be the trace of this matrix or sum of the diagonal elements of this matrix, right? So sum of diagonal elements means when for A square, the element of first row, first column will be first row multiplied by this first column. Remember, it is given that trace of A square, this is 1. Now trace of A square means first row, first column, this will give us A square plus C square, right? This will be the element of first row, first column of A square. And similarly, element of second row, second column, this will be C square plus B square, right? And this has to be 1. We are not calculating the element of first row, second column or second row, first column, because trace means sum of diagonal elements only. Now from here we are getting A square plus B square plus 2 square, this must be 1. Now ABC are integer, and A square plus B square plus 2C square, this must be 1. So then we have to see what are the different possible values of A, B, C. Now as these numbers are integer, for this variable C, we have only one option, and that option is C must be 0. Because if you take any other value of C, then you cannot make this sum 1, right? If I take C as 1 or minus 1, then this term itself will be 2, and then we have other positive term, whereas the right hand side is 1 only. So for C there is no option, the value of C must be 0, and if C is 0, then the equation becomes A square plus B square, this equals to 1. Now what are the different integral solution of this equation? So one possibility is that you can take A as plus minus 1 and you can take B as 0, or another possibility will be that you can take A as 0 and B as plus minus 1. These are the only two possibilities. In fact, four possibility, plus minus 1 and 0. So one matrix will, in all of those matrices, the value of C will be 0. So there will be two matrices for which C is 0, B is 0, and A is either plus 1 or minus 1. And there will be other two matrices for which A is 0, C is 0, and B is plus 1 or minus 1, right? So clearly you can see that there will be four such matrices with integral entries, right? 4 2 cross 2 symmetric matrices with integral entries for which trace of A square, that will be 1, right? So therefore, the correct answer for this problem must be second option. So, this was not difficult problem. All we had to do was start with a general 2 cross 2 symmetric matrix. And in case of symmetric matrix, element in ith row, jth column, this must be same as element of jth row, ith column. So from there we got A square plus B square plus 2C square as 1. And now value of C must be 0. Then the equation was A square plus B square is 1. which means A is plus minus 1, B is 0, or A is 0 and B is plus minus 1. So total there are 4 such matrices, and therefore the correct answer for this problem is option B.